Hello guys, welcome back to Quadratic Equations and Functions Revision. Here we are on problem solving, and today there's going to be a really hot and complicated task. So its complexity actually depends on how well you know the topic about rates. Okay, let's get started. Let's go down. So we've covered 6 tasks in a row, 6 problems in a row dedicated to different types of problem solving. So seems to me it's good training stuff. All right, so here is the task or the problem that you can consider. So I'm not sure whether you're already solved that. If yes, share your opinions, share your answers in the comments. If not, just let's try to do it together. Okay, so we've got 2 waiters, Anna and Rebecca. Each should serve 150 tables in the cafe. So obviously it's not like for one shift definitely takes more. 150 tables, that's really a lot. So it depends on how often. But in average, okay, we see that Anna can serve 5 tables more each 2 hours. The keyword here, 2 hours, not each hour, but for every 2 hours, Anna can serve 5 tables more. Okay, then Rebecca, and she finished her work and duty 1 hour early. So how long does it take for each girl to serve all the tables? All right, so I'll just erase a little bit what we had before. Yeah, just erase it for not to mess up. All right, so let's try to remember the general approach. How we used to solve problems requires from you knowledge of what rate of change is, or just rate of work. Okay. So any rate of work, we can input a new term probably for you. It's a work done. So no matter what actually sort of work the person does. For example, it might be some tables served. It might be pieces produced. It might be, I don't know, area of the street, so meters squared. That actually cleaning stuff is trying to tie it up. Okay, so any work, no matter which units you use for work, it might be, as I said, different units, per time required, okay? Per time required, so that's necessary. In this case, we've got hours. So you might consider any amount of hours. So I'll give you some examples. For example, rate of change for the traveler to cover certain distance. So distance, it's distance over time. The units meter per seconds, for example, okay? So that's the units of rate of change. So rate of change in distance. As we know, it's speed, right? Or velocity. But we consider like scalar, so it's about distances traveled. So that's the speed, right? So distance traveled per time. In this case, rate is speed. Any other examples? For example, you have a cleaner and cleans the street. So a certain area, so area cleaned per time. That's also rate of how area is changing over time. So clean area changing over time. So for example, might be meters squared per hours, let's say. Okay, so you see lots of examples here. And in this case, we input the rate as some work done. So I erase because I need a space. The space is really crucial for me. All right, so we've got some work. In this case, units are tables. So we put tables here. Tables. And which sort of work we're considering here. All right, so I put index A for rate of Anna. Let's say rate of Anna is RA. And we know some work per hours, per time, right? Per hour, per 1 hour, let's say 1 hour. Okay, so what about Rebecca? So Rebecca, let's say R stays for Rebecca. Her rate of how many tables she served is another work with actually per 1 hour. But the problem is you need to connect those rates, right? Because you have the statement that allows you to connect. So what about the statement? Anna can serve 5 tables more, each 2 hours, okay? So how it looks like in terms of the equation? We can state that if Rebecca works some amount of tables served, and this work is W, so what about how the connection this work with Anna work? 5 tables more each 2 hours. So we can say that for every 2 hours, we can say that that's plus 5 tables more, but not for 1 hour now, but for 2 hours, okay? The same as for Rebecca, right? We can say it's work done for 2 hours, okay? And Anna works better because she got 5 tables more. So that's the rates. So what we can do, we need to connect them, right? Definitely. We don't need to know like works for every 2 hours. So that's why we want to exclude W. So I express W from there. So W is simply 2H rate of Rebecca, and we just simply put there. Okay, so that's why, and I simply also multiply by 2 both sides. So I've got 2 rate of Anna is actually, now we've got denominator is 1 hour. So I've got 2 hours times Rebecca rate and add 5. So hours units, right? So you can actually eliminate them, because hours is just units. So we've got simple equations without any units. But we understand that rate of something, like rate of serving the tables, is simply tables over time, over hour. Okay, so we've got one equation that connects rates of each person. And that's in every single task. No matter what you're actually solving, you can solve about motion. In this case, you'll have comparison of speeds or velocities. So in case of other tasks, you always compare the rate. So this is a must-have equation in any specific problems relating to works. All right. So here we have the next one. It means Anna, finished her work duty 1 hour early. All right. Because each person needs to serve 150 tables, we can set up the equation for 150 tables. Can we? Yeah, we can. Okay, so in this case, what we are going to have 150 tables. So I simply say that, okay, we have Rebecca. It's better to start from like formula. So what about rate? So here, that's the rate for any person. And that's why we can say that for Rebecca, she needs to serve 150 tables, that's the work, over time. Let's input some time, t, okay? So some t hours. So what about the rate for Anna? We know that Anna needs to, so she's can cancel, she can finish her working duty 1 hour early. So that means for the same amount of tables, that's the same work, she needs to have less time for that. 1 hour less. Okay, if time and hours, we can set up this sort of equation. And now what I'm going to do, I'm going to connect those two equations into one, okay? So I express time from there, and we know that time is simply 150 over Rebecca rate. Can we input there? Yes, we can. So what about rate for Anna? It's going to be 150 over. And now what I've got in denominator, I've got 150 over R, Rebecca. And here I simply subtract 1. So what I can do, I want to have the same denominator, so I can put instead of 1, I just simply put minus Rebecca rate over Rebecca rate, because during the cancel you'll get 1. Okay, why I need that? Because I have Rebecca rate in bottoms for 2 denominators. Alright, so I simply 150 divided by, let's simplify that. So 150 minus Rebecca rate, so I'm just divided by a fraction, which has the common denominator Rebecca rate. And here I've got 150 minus Rebecca rate. But when I'm dividing a number by a fraction, so what am I supposed to have? I'm supposed to have 150 actually times by a reciprocal fraction. That's what I'm going to do now. Okay? So yeah, that's Rebecca rate over 150 minus rate, or 150 goes simply here on top. So that's why I've got 150 Rebecca rate over 150 minus Rebecca rate. Now what I've got that this is equal to Anna rate. Okay, and this is the second equation in a row. So we first connected rates for Anna and Rebecca through the first statement about how each person does its job, right? His job, okay, or her job. So in this case, we've got another equation using another statement about who finished the work earlier. Okay, that's the second part. Now, what am I going to do? That's quadratic equation supposed to be in the end. So we are actually looking for how to solve the system of equation. This is an equation 1 and this is an equation 2. So what I'm going to do right now, I'm going to say that Rebecca rate is simply that 1 over 2. Okay, let's do this. So Rebecca is simply, I'm divided by 2 everything. So I've got Rebecca rate and 5 over 2 in the end, so 2.5. Can I plug that part here? Yeah, of course, sure. And definitely I need to do that. So what I've got Rebecca rate plus 2.5 equals to this fraction. Okay, so that's what I've got. The trickiest part is how to complete equations. So later on, the second trickiest part is how to solve them. But if you're okay with like combination of linear with quadratic equations and simultaneous equations, you can do that. All right, so let's try to figure out. So what I'm going to do, I imagine that here is 1 and I use the fractional equation solution. So I crisscross multiplying and hence I can get the values for our equation for Rebecca rate. So now you see we got only Rebecca rate and that's what we need to find. Okay, so let's multiply that. So I've got 150 minus Rebecca rate when multiplying by Rebecca rate plus 2.5. So what I'm going to have on the right side, I've got 150 Rebecca rate, or I subtract and transfer it to the left side. So I've got that. Next one, I'm just trying to expand the brackets. So I've got 150 Rebecca rate plus 150 times 2.5. Then I do the same with Rebecca rate squared. And here I got also 2.5 Rebecca rate. And I also subtract 150 Rebecca rate, the last term here. Okay, so what I'm going to do, I just want to simplify that. So I've got that here, which is cancel obviously. And I'm going to left with that equation. Okay, so I just shift a little bit here. So I start from the square term. Then I'm simplifying that expression, 150 plus 2.5, so I'm doing that. 150 times 2.5, I've got 375, so plus 375 equals to 0. So what I'm going to do, there are two ways to multiply by -1. in order to have good quadratic equation. So I'll do that, and I'll have squared, positive, and negative 375. Simply I'm swapping the sides. Okay, so now what I'm going to do, I'm going to use quadratic formula again, because you see the numbers, that looks like awkward and quite big, so you cannot do by, completed square factorizing. So it seems to me quadratic formula is best working here. Okay, so let's calculate. So that's quadratic equation, so I'm using discriminant first. Discriminant is 2.5 squared and plus, because minus 4ac, so plus 4 times 375. Okay, and next I'm going to find Rebecca rate as minus 2.5, that's minus b, plus minus square root of this thing, okay, of discriminant, and over 2a. Okay, so let's calculate the first solution for that. Let me see. So what I have, so that's the only solution, because if you subtract minus 2.5 and minus discriminant, no matter which discriminant is, we've got negative solution. So we've got only the single one, positive rate. So now let's calculate. So minus 2.5, then plus square root of discriminant, which is again 2.5 squared, and then plus 4 times 375, it's here. Okay, and now we everything divided by 2. So I've got 18.16 hours. Sorry, not hours. That's what we found. We found the rate for Rebecca. So that's the rate. We've got we've got tables per hour. Okay, tables per hour. So now, how many hours we need for 150 tables if we use this rate? Okay, so that's the work done, which is simply, if we rearrange this equation, we can get the work done in time, right? So actually what we need time in hours. So we need to rearrange so that we can get the time from there. So time from there is always work over rate. So now we use 150 tables and use Rebecca rate now. So that's Rebecca time. So we've got W 150 and we divide by 18.16. Okay, let me see, 150 over 18.16. So we've got around 8 hours and something. So around 8 hours required for Rebecca. If we know that Anna finished her working duty 1 hour early, what can we say? We can say that time for Anna is simply 1 hour less. So it's around 7 hours. Okay. So guys, that's how it works. That was pretty tricky task, because task for work done is always the trickiest one, and also many students have difficulties with. All right, but we completed. So hope you understand that. If not, just go back one more time, go through the video and try to see what actually each step, try to track each step. Only then you can get the right track, and by practicing you enhance your skills of doing such problems. Hope you like that. Don't forget to subscribe, because in that case you'll be in touch with the latest updates. Okay, and smash the bell button as well. Daniel Dallas, see you.